Hello, so we're now going to our second part of quadratic equations. Uh, so, Hello, so we're now going to our second part of quadratic equations. So now we have sum and product of quadratic equation. We're going to be looking at sum and product of quadratic equations. Now here we see they're asking us find the quadratic equation whose roots are 3 and 2. So how do we find this? So meaning if they're telling us that the roots are 3 and 2, so they're asking us to find the quadratic equation whose roots are 3 and 2. So we say that roots of a quadratic equation are the values that solve that quadratic equation. So now, for this case, they're telling us that the roots are 3 and 2, and they want us to find the quadratic equation. So we can say, so maybe if we choose the x to be the variable, we can say, so the roots are 3 and 2. So x is 3 or x is 2. So now how we solve this, we now bring this side. This is equals to 0, or x minus 2 is equals to 0. So we now have this. So we multiply these two, x minus 2, this is equals to 0. Multiply these two, then now we open the bracket. So we have x into x minus 2 minus 3 into x minus 2 is equals to 0. So what do we have? We have x squared minus 2x minus 3x plus 6 is equals to 0. So what do we have? X squared minus 5x plus 6 is equals to 0. So we have found the quadratic equation whose roots were this and this. And when you try to solve it, you'll actually get this as the roots. So now how about this one? Find the quadratic equation whose roots are 6 and 2. So what does that mean? Our x after solving would have been 6, or our x would have been 2. So we do the same thing. X minus 6 is equals to 0. X minus 2 is equals to 0. So we multiply these two factors. So we now open the bracket. So what do we get? X squared minus 2x minus 6x plus 12 is equals to 0. So we have x squared minus 8x plus 12 is equals to 0. So we found the quadratic equation whose roots were 6 and 2. So that's the answer. Now we now have so now we have this. We have consider a quadratic equation ax squared plus bx plus c is equals to 0 if the quadratic equation has roots alpha and beta. Remember, we said that the roots of the quadratic equation are the values of x. That's if x is the variable that solves the equation. So we are assuming that this quadratic equation has roots alpha and beta. So that means x is equals to alpha or x is equals to beta. So we now say this is x minus alpha would be 0 or x minus beta would be 0. Then now we multiply this x minus alpha into x minus beta is equals to 0. So we want to form the quadratic equation that form these two. So now then we open the bracket. This is minus alpha into x minus this is equals to 0. Now here we have x squared minus this plus this is equals to 0. So now we have x squared. So this we can collect like terms, factorize out the x such that we have this is equals to this plus alpha and beta. So we now have this as our quadratic equation. But remember, alpha and beta are the roots of the equation. So this can also be written as x squared minus the sum of the roots plus the product of the roots is equals to 0. Now this is a very important thing in quadratic equations. Realize that anytime you're given the roots, you don't have to actually go back. Let's give an example here. You have the roots 3 and 2. You don't have to even go this side. You just know that x squared minus sum of roots x plus the product is equals to 0. So now here what are our roots? So it's x squared minus 3 plus 2 x plus the product 3 times 2 is equals to 0. So this is x squared minus 5x plus 6 is equals to 0. So you see we've solved this equation without having to go all this way. Then now we have another thing here. Roots are 6 and 2, but what does our formula say? X squared minus sum of roots x plus the product is equals to 0. So what does that mean? If you have x squared and the sum, this is 6 plus 2 minus 8x plus what is the product? 6 times 2 is 12. This is equals to 0. So that's why I'm saying this. Sorry, let's now come back. This is a very important thing in quadratic equations. So that x squared minus the sum of roots into x plus the product of roots is equals to 0. It's a very important thing. Now, another thing, so you should have this at the back of your mind always as you're doing any numbers. Actually, there's going to be a small exercise towards the end of this session where I encourage you to do those numbers. Okay. Now we now also have let's remember our general equation that we had at the start. With the general equation for the general term for our quadratic equation is ax squared plus bx plus c is equals to 0. So is equals to 0. So we divide through by a, divide through by a, divide through by a, divide through by a. So we have x squared plus b out of a x plus c out of a is equals to 0. We have this. Then now I'm going to bring this. So then we also had x squared minus b plus alpha x plus alpha beta is equals to 0. So now we're going to compare coefficient. Remember I told you by comparing coefficient, I mean we are comparing the number just before the term. So here for x squared, the coefficients are the same 1 and 1. Now for this, we're going to, for the coefficient of x, comparing the coefficient of x, it's negative b plus alpha is equal to b out of a. So what does that mean? If you have beta plus alpha is equals to negative b out of a. This beta plus alpha is representing, remember we said if the roots of the quadratic equations are alpha and beta. So meaning the sum of the roots will always be equals to negative b out of a. Then the product of the roots by comparing coefficients will always be c out of a. Yes, so now here there are 3 or 4 important things you have to get away with. That the sum of roots of a quadratic equation will always be negative b out of a, and the product of the roots of a quadratic equation will always be c out of a. This becomes very important in solving very many numbers regarding quadratic equations, and we've seen how it comes about. Now let's look at a few things to see what is the use of this concept. Now here we're given a question saying find the sums and the products of the roots of the following equations. They want us to find the sum and the product of the roots. Okay, so if you didn't know anything about this, you usually say you solve the equation, find the roots, then now you add the roots and multiply the roots to get the sum and the product. But no, that's not what we have to do for this case. We have 2x squared minus 11x plus 3 equals to 0. So now here, what is our value of a? This is 2. What's our value of b? Negative 11. What's our value of c? 3. But what did we say from the previous bit? That the sum of the roots is equals to negative b out of a. So what is the sum of the roots? This is going to be negative into negative 11 out of 2, which is a. So the sum of the roots is 11 out of 2. How about the product? We say the product of the roots is equals to c out of a. So the product of the roots will be 3 out of 2. Now we are going to modify how we are doing it. So here, for let's say for this part b, you have 2x squared plus x minus 1 is equals to 0. So we always try to make sure that the coefficient of the x squared term is 1. So say I'm dividing through by 2. So we have x squared plus x out of 2 minus a half is equals to 0. Okay, so this is what we have now. So here we can just say what is the sum of the roots is equals to negative b out of a. But now here we already divided by that, so the sum of the roots would be negative a half. So and then the product will be, which is the product is c out of a. So the product would be negative a half. So that was just my example, but you can now work out all of these. Though these may need you to first do some LCM, but eventually it would come out to the same thing. You're going to form a quadratic equation. After forming the quadratic equation, make sure you rearrange it in the form of ax squared plus bx plus c equals to 0. Then after that, you can obtain the sum from negative b out of a and the product from c out of a. Yes, then now for example this one part C, you rearrange it, you bring the x this side, you bring the constant that side, then you solve the equation. Okay, now we have these find equations with integral coefficients and then find the sums of the product of the equation whose roots are respectively. So now here they want us to find equations. Remember at the start how we would have done this, would have said x is equals to 3, x is equals to 4, then we expand like that until we find an equation. But now from what we've learned, know that if I have the roots of an equation being 3 and 4, we saw that x squared minus the sum of the roots into x plus the product of the roots is equals to 0. So means I can form an equation whose roots are these without having to go all the way. So I can just say what's the sum of these roots? 3 plus 4 is 7. What's the product? 3 times 4 is 12. So my equation is x squared minus the sum, which is 7x, plus the product, which is 12, is equals to 0. So I have found the equation with integral. I have found the equation. This is our equation. Okay, then now the sum and the product of the equation. So you see, I already have the sum, I already have the product. So now that's the same thing we're going to do for all of these. So now we also come here, the b, this is negative 5 and 6. So we find what is the sum. The sum of the roots is negative 5 plus 6, which is 1. What is the product? The product is negative 5 times 6, which is negative 30. So this is negative 30, that is what we have. So we are going to say x squared minus the sum, the roots into x, plus the product is equals to 0. So this is x squared minus x minus 30, because this is already negative. So, okay. So this is our equation. So we do that same thing for this. C, the roots are negative 3 out of 2, so still you get the sum 3 out of 2 plus negative 5 out of 2. You can use your calculator, then you get the product. This would be 3 out of 2 times negative 5 out of 2. So here we have, okay, we have what is 3 minus 5 divided by 2. This is negative 1. Then here we have negative 15 out of 2. So we now just come and say x squared minus the sum into x plus product is equals to 0. So this is x squared minus the sum, but now the sum is minus, so minus x plus the product, which is negative 15 out of 2. So now have x squared plus x minus 15 out of 2 is equals to 0. Sister question said they want equations with integral coefficients, and this is not an integer, so we multiply through by 2 such that so we get 2x squared plus 2x minus 15 is equals to 0. So now this should emphasize more what I mean by the sum and the product, and why it's very important to know the sum and the product. Okay. Now we are moving on. The question here says the roots of the equation 2x squared plus 3x minus 4 is equals to 0 are alpha and beta. Find the values of this, and this. Now here, the main concept in this case is knowing how to simplify these terms into like expressions of alpha plus beta and alpha. So I'm going to show you how what I mean. So we have this equation. So the equation is 2x squared plus 3x minus 4 is equals to 0. And they are saying the roots of the equation are alpha and beta. So we can find the sum, like alpha plus beta, and even alpha beta. Why? Because we know that alpha plus beta will be negative b out of a, and alpha beta would be c out of a. So there are very many ways you can, but let's just say a is 2, from this b is 3, from this c is negative 4. So what is alpha plus beta? Negative 3 out of 2. What is alpha beta? It would be negative 4 out of 2, which is negative 2. So we have alpha plus beta being negative 3 out of 2, and we have alpha beta being negative 2. Okay, so we now have this. But now the question, part A wanted us to find alpha squared plus beta squared. So they want you to express this alpha squared and beta squared in terms of alpha plus beta such that you can substitute these. Now, there is no way we can break this down. We are now going to use another term. We're going to say, let's consider alpha plus beta squared. Now, I'm going to allow everyone to do this on their side work. We're going to realize that alpha plus beta squared is going to be equals to alpha squared plus 2 alpha beta plus beta squared. This is what you get. Now, here we realize when you look at this keenly, you can realize alpha plus beta squared is equals to alpha squared plus, I'm bringing this close, plus beta squared plus 2 alpha beta. So you see, my expression is here. So I can just make this the subject. So I can just take this side. So I'll realize alpha squared plus beta squared is equals to alpha plus beta squared minus 2 alpha. So I'm just making this the subject, and this is what I have. So now, meaning to solve my equation here, I can alpha plus beta squared, so this squared is going to be equals to alpha, this which is negative 3 out of 2 squared minus 2 into negative 2. So now this becomes very simple to solve. So that's why I told you that all these equations, as long as you can simplify this to have an alpha plus beta or an alpha beta, it's going, that is all. Then you can substitute this. You're going to be able to solve all these numbers. And now what I'm going to be helping us with is just to show us how we can simplify it. Then you can eventually substitute on your own. So this, you just put the value into your calculator, and then you'll have solved this. So now let's look at part B, where we have 1 out of alpha plus this. So now here all we do, we get the LCM. So we have beta plus alpha. So you see we have come up with alpha plus beta out of alpha beta. So we can now substitute this and find the answer. Now let's see about this. Now this and this are going to be obvious. You'll try it out and see. Yeah, you open this bracket, you will see it will come out, then you substitute and find the answer. Even this, it will come out almost similar to this, then you solve. So anytime you have alpha squared plus beta squared, with time this thing should stick with you, that always when you have alpha plus b squared. But for now, you should know how it comes about. Okay, now we have this. If the roots of the equation are alpha plus beta, find the values of this. Now, as I said earlier, if you have an equation, you should be able to find the sum, you should be able to find the product. But now they want us to find the values of this. So let's now, I'm just going to help us simplify it. Then you will substitute on your own, then you find the answer. So here we have this. When you factorize out this, what do you have? You have alpha, you have this. So you can substitute your values you've gotten. And now here you have alpha squared minus alpha beta plus beta squared. So now here we can, this becomes alpha squared plus beta squared minus alpha beta. And remember, we simplified this in the previous part. This is alpha plus beta squared minus 2 alpha beta minus alpha beta. So this is alpha plus beta squared minus 3 alpha beta. You can substitute this and substitute this, and you further simplify that. Then now we go to part C. Now part C is telling us, part C is saying alpha cubed plus beta cubed. So similarly, the way we did last time, we were going to come and say what is alpha plus beta cubed. Now this, I'll refer it video on Pascal's triangle. It's going to make it simple for you to expand all these expressions. So I'm going to pause the video, and then I'll replay it when I've expanded this. Okay, so now when you expand this, what do we get? So we can all do our side work. So for me, from my side work, I found out it's alpha cubed plus 3 alpha squared beta plus 3 alpha beta squared plus all of us can pause our videos and then go and work this out as our side work. So now this, I will have alpha cubed, but I can simplify this to have 3 alpha beta into alpha plus beta. Like that is from this. I've pulled out 3 alpha beta, collecting like term this. Then I'll bring this side. So I have alpha plus beta cubed is equals to alpha cubed plus beta cubed plus 3 alpha beta into alpha plus beta. So I'll make this the subject. Alpha cubed plus beta cubed is equals to alpha plus beta cubed minus 3 alpha beta. You see, so we have this. Now when you have this, you already had you've obtained this from your equation, so you can substitute them and solve part C. Now for part D, same thing, you have alpha squared beta plus beta squared out of alpha. We get another color. Okay, so we have this would be equals to beta alpha, then here when this will be alpha cubed plus beta cubed. So you see we can now, this can be simplified to this, then you substitute and solve it further. Okay, now let's see. Yes, so I told you there would be some numbers for us to do at the end, so these are numbers for you to try out. You can try out, the answers are there, but I told you the main thing is to know how to factorize, and you can confirm your answers with the answers we have at the site. Okay, now we have this. Find an equation with integral coefficients whose roots, find an equation with integral coefficients whose roots are the squares of the roots of the equation. So they want us to find an equation, you can ignore this, with integral coefficients whose roots are the squares of the roots. So meaning we are going to let the roots of this equation be alpha and beta. But for them, they want us to find an equation whose roots are the squares. So the equation we want to find, its roots are alpha squared and beta squared. So for us, we have our equation is 2x squared plus 5x minus 6. But its roots are alpha and beta. That's what we've let them to be. So we now come and say, we remember alpha plus beta is equals to negative b out of a. So with time, you don't even have to say what is a, what is b, what is c. You can just say alpha plus beta would be negative 5 out of 2. And what is the product of the roots? The product of the roots would be c out of a. So alpha beta would be negative 6 out of 2, which is negative 3. So we found the sum of and the product of these roots. But now we want to find an equation whose roots are these, the squares of these roots. But we said for any quadratic equation, x squared minus the sum of the roots into x plus the product is equals to 0. This gives us the quadratic equation, but while using the sum and the product. So meaning, if we can find the sum, which is alpha squared plus beta squared, in our earlier example, we realized that alpha squared plus beta squared would be alpha plus beta squared minus 2 alpha beta. So what would this be? This would give us, this is negative 5 out of 2 square root minus 2 into negative 3. So here what do we get? Alpha squared plus beta squared. So here we get our answer as 49 out of 4. We get our answer as 49 out of 4. Okay. Then for the product, alpha squared, beta squared, this would be negative 3 squared, which is 9. So we have the sum, so we can now just say x squared minus the sum, which is 49 out of 4, plus the product, which is 9, is equals to 0. But the equation said they want integral coefficients, so they don't want fractions. So multiply through by 4, what do we have? 4x squared minus 49 plus, minus 49x plus 36 is equal to 0. And we've solved that. Yes, and then now we can try out these numbers. We see this one says the roots of the equation are alpha and alpha minus 1. Find the value of q. So this is the same concept. These are the roots. So you know what the sum of the roots is equal to, what the product of the roots is equal to. So with that, you can be able to find the value of this alpha. After finding the value of alpha, you can use that to find the value of q. If you have any questions, you can let me know. And then here we have the roots of this equation differ by to show that. So we are now going to have a final video. We shall have a video just with proofs, talking about the proofs in quadratic equations. So we are going to do all these proofs, including this. So this is not part of the immediate assignment, but now this is part. Okay. So these proofs And these questions okay, now we are looking at questions having a common root or a common factor. Now here you see this question, given that 2x squared plus 7x minus 4, this and this have a common factor, find part A is telling us to find the factors of this and this. So now we have question is asking us to find factors. So we have 2x squared plus 7x minus 4. Let's start with this one and find its factors. So we're going to use a factorization method. So we're going to say sum B is 7, product SC. I referred our video on solving quadratic equations using the factorization method. Here this is negative 8, so we come and get the factors of negative 8. 1 times negative 8, 2 times negative 4. We have this, but we can also have negative 1 times 8. We can also have negative 2 times 4. These are also factors, numbers that will still give you negative 8. So we have to get two of these that when you add, they give us 7, but when you multiply, they give us negative 8, and I think they give us 7, sorry. So we realize that negative 1 and 8. So negative 1 and 8. So we're going to say into say 2x squared minus x plus 8x minus 4 is equals to 0. Now forget that if you're solving a quadratic equation, you should equate it to 0. So here we're collecting the like terms. So this is minus 1. So even here we have 2x minus 1. We take out 4 is equals to 0. So x plus 4, and this is 2x minus 1 is equals to 0. So we've found the factors. Though you can go ahead and solve it, but the question wanted us to find the factors, and these are the factors. So we can now also say about x squared plus 3x minus 4 equate it to 0. So the sum of B should be 3. The product SC is 1 times negative 4, which is negative 4. Then now we come here and say negative 4, what are the factors? 1 times negative 4 and 2 times negative 2. So we have this, but then we also have negative 1 times 4 and negative 2 times 2, which is the same thing. So we get which of these that when you add will give us 3, and in this case it's negative 1 and 4. So x squared plus x squared minus x plus 4x minus 4 is equals to 0. So I say this will be x minus 1, even this into x minus 1, then this is plus 4. So I have x minus 1 into x plus 4 is equals to 0. This is equals to 0. So now these are the factors, they are the factors. So I think when you look at this, the factor here in this equation and the factor here that is common, so we have our common factor. The common factor is x plus 4. So what is the common? The common root, it will be x plus 4 is equals to, the common root is x is equals to negative 4. This is the common root. Now we can go to the next part. The next part is asking, so now the next part is asking us to find the value of a in this 7x plus ax minus 8. But we know that the common root is negative 4. So we can equate this to 0. And now we know that if this is a common root, that means if you substitute this into this equation, it should be able to solve it, be able to give 0. So now I say 7 into negative 4 squared plus a into negative 4 minus 8 is equals to 0. So now I have what is 4 squared. Here I have 1, 1, 2 minus 4a minus 8 is equals to 0. So now with this we can solve this and see what is 1, 1, 2 minus 8. This is 104 equals to 4a divided by 4 divided by 4. Our value of a will be 26. So we've solved this equation. So we solved the equation and found the value of a.